Let's take some time to talk about basics of functions and what a linear function is. So when we talk about what is a function, well, a function can be related to basically a machine. There's an input and an output. Your output, what you get out of your machine, is going to depend on what you put in it. So if we have our function machine, I start with putting something in it. That would be my materials. And then the machine is going to do all the work. It's going to build my product, and then it's going to give me my output. Well, what does that look like in math? Let's take this tree, for example. This tree grows 20 centimeters every year. So every time we hit a new year, it grows 20 centimeters. So we could say that the height of the tree is related to the age of the tree. When we're dealing with math and functions, we want to always specify a variable. So we're going to say h represents the height and a is going to represent my age. So I could say that my height is going to result as I multiply the number of years times 20. What I've just created here is a linear function. So here's an example of what we're used to seeing in algebra. Some of us pre-algebra. I have an equation. My equation is my machine. That is the relationship. It describes the relationship between x and y. X is going to be my input. It's what I'm going to put into my machine. I then do the calculating and I get back my Y. Now what gets confusing is, well, what X? What X do I use? Well, when we are doing what we're doing today, we can pick an X, okay? We can pick a specific X, plug it in, and it'll generate a Y. So let's go take a closer look at what my X's are and what my Y's are. When we come into math, we call all my possible X values. So any X value or my input, those are the same thing, we call that the domain. So my domain is all the X's that I'm putting into my machine. Now the Y values, that's my output. That's what I got back out of my machine as it did its calculating. That's called my range. When we're looking at a function, any type of function, it doesn't matter if it's linear, quadratic, exponential, cubic, X cannot repeat. If X repeats, it's not a function. Because the definition of a function says for each X, there is exactly one Y. I can't plug in an X value and get two different Y's. So let's look at what that means for domain and range. Okay, so here I have a set of ordered pairs. This is a relation. As we know, a relation is a function. So let's take a look at letter A. I'm going to identify my domain. Well, we had just talked on the previous slide that my domain is all my possible X values. So let's go through A and circle all my X's. Okay, here's another X, another one, and my last one. So I can say that my domain is -2, 0, 4, and 5. It also wanted me to identify my range. So I'm going to look at all my Y values here. Okay. So when I go and write my Y values, I'm going to only write this 2.5 once. Even though it's there twice, I write it once. So then the second part to this question, I've identified the domain and I've identified the range. They want to know, is it a function? Well, let's go back to what we just did prior. A function is when X does not repeat. Y doesn't matter. I can have the same Y all the time. I'm focusing on my X value. And since in this example, when I look at all my X's, nothing repeated, It is a function. So let's go, we're to the same thing with letter B. If I take a look at all my x values, okay, notice here, 6 repeats. I'm only going to write it once in my domain. Let's go take a look at my y values. When I write those, that's my range. So my other question was, is it in fact a function? Well, if I go back and look at my domain, and I look at my x's that I circled, there's 2 6s there. Therefore, no, it is not a function. So now that we've gone through a couple examples, it's a good time to pause the video and try these two on your own. My recommendation is to actually write the relation down. Write down A and B, do the circling, state the domain and range, and take a look and see if they are in fact functions. Okay, let's take a look and see how you did. On letter A, if we go through and we circle all of our x values, I notice that 4.2 is there twice, so I'm only going to write it once. If I go through and circle all of my y values, okay, and then I write them down for the range, okay, remember, what am I looking at? I'm looking at my domain. I want to see if my x value repeated. It did, so this is not a function. Okay, so let's take a look at B. I'm going to go through and I'm going to circle all of my x values. When I go down and I write them, I now have my domain. After that, all of my y's to give me my range. Again, to determine if it is a function, I'm looking at my domain, all of my x's. It is a function because x does not repeat. So that's how I would determine if it's a function based off of ordered pairs. There is something as well called the vertical line test. So this is very straightforward, very simple, but for some, they can get confused sometimes. A vertical line test is when I have the graph of the function. Okay, let me fix this video for you so you can see a little better. Okay. If I drew a straight line up and down, I'm going to notice that the graph of my function only touches in one place. When you see that happen and the graph is only touching in one spot, okay, those are in fact functions. When I go over and I look at these 4 graphs, I draw my vertical line, I have 2 places it touches. Again here, 2 places. On this one, there's 3, and on here it's 2. So therefore, if it's touching in 2 or more places, it is not a function. Our goal is to have it only touch in one spot. So let's see what that looks like for us if we were to go do it and the graph not already have the line on it. So you might be given a discrete function. A discrete function is when you have set points, meaning there's nothing in between. There's no possible values in between. It's a fixed data point. That doesn't change the vertical line test. If I draw a straight line, oh, 1 point's touching right there. But you got to test some other spots because look right here. I now have 2 points touching. Okay, so therefore that one is not a function. Here I have my parabola, which this one we'll get to in more detail with quadratics, but it's called the parabola. If I draw a vertical line, it's only touching that line in one place. I can draw another one somewhere else just to confirm. And again, it's only touching in one spot. So yes, it is in fact a function. now's a good time to pause the video and try these two on your own. If you like to sketch it in your notes, you can. That way you can actually draw the vertical line or hold your pencil up to the computer screen. Okay, let's take a look. On this first one, if I draw the vertical line there, only touching at one point. If I draw it here, it's still only touching at one point. So on my second graph, touching at one point. It doesn't matter where I draw it. Therefore, both of these are in fact functions. So my graphs that are just fixed points, those are called discrete functions. And then my graphs that are a line or a shape and they're connected, those are continuous. And we will do another video on that. You can look through the YouTube channel for one of those. So now this leads us into a specific type of function that we're going to focus on with this video. These are called parent functions. A parent function is the basic. It's just y equals x or y equals x squared. Now I know I'm saying y equals and you see an f of x. F of x is basically a fancy way of saying y. That is function notation. So with a parent function, they always go through the origin. The center of the function goes through the origin. So in a quadratic, your vertex is going through the origin, your minimum or your maximum. Same thing with absolute value. So let's talk about the first parent function we saw there, a linear function or a linear equation. What a linear equation is, it's written in one or two variables. No variable is raised to a power greater than 1, meaning the exponent on any of the variables is always 1. No other exponent. And the reason why you don't see the 1 there is because remember it's a ninja 1. So if I have an x or I have a y or a b or an a and there's no exponent to it, it's 1. Then what happens is in a linear function, when you plug in an x, you put your input in, you get back your output, you're generating ordered pairs. Ordered pairs are basically solutions of the equation that make it true. When you go plot all of these ordered pairs, they fall on a line. It could be a slanted line or a straight line, up and down, okay, or left to right, I should say, not up and down, because then it's not an actual function. It's linear, but it's not a function. So the direction of the line may change based off your quote-unquote machine, which is your equation. So let's go take a look at what that means. So in a linear equation, there are 3 forms, okay? You have something called point-slope form, slope-intercept form, and standard form. All of these forms can be changed into slope-intercept form. We're going to spend some time focusing on slope-intercept form today because it's the most common and the easiest to work with. So let's just go back for a second before we get started. And remember that the equation you're working with is your machine. I put in an x to get back out a y. The reason this is important is because I'm generating solutions for my equation. So let's take a look at this one equation. I know it's linear. And it's linear because I have an x and I have a y. Both of them have an exponent of 1. What I can do is I can create a table, meaning I can plug in an x. Where did I get these numbers from? Well, you can pick them. And the numbers can change based off your equation. Don't go and pick gigantic numbers because it's not going to make it easy to graph. So you want it to be as simple as you can for graphing purposes. So if I plugged in 0, okay, what I have to do is I have to do the math. 2 times 0 minus 6. Remember, x is my input, so I plug it into x. I do some calculating and I get my y. Right there, I have a solution to my equation that makes the statement true. And then I'm going to plug in 1, and I'm going to do 2 times 1 minus 6 is 2 minus 6, which is negative 4. I'm basically generating the sum of the solutions on my graph. Then I have 2 times 2, which is 4, minus 6 is negative 2. Now, I personally know this is a linear equation. If you take a look at your equation, okay, this is in the form of y equals mx plus b. And we're going to get into that a little later. But you can see that it's a linear equation when you go plot your points. Here I have 0, negative 6. Then I have 1, negative 4, and 2, negative 2. I've got my 3 points, I can connect, and I've been able to graph my line. The reason we want to do this is because I can then, from the line, find some other solutions and make predictions. Because you can go look, if you take a look here at this point, when x is 3, y is 0. And I can see that because my line is touching that point. So a table and a graph helps you to better understand where you're going or make a prediction. So now it's your turn. So I want you to use a table to graph. Now I've come up with these numbers, and the reason why I picked these in particular is because it's going to be easier to work with when you plug into your equation or your actual machine. I like to use the word machine. So pause the video now and try these on your own. Okay, let's see how you did. If we start with our first table and we plugged in our negative 1, you should have gotten 3. So we plot negative 1, 3 on our graph. If you plugged in 0, you should have gotten 1, so that you'd have 0, 1. That is your y-intercept, and we're going to talk about that in a minute. When you take the 1 and replace your x, put your input, your output should have been negative 1. So that I'm at 1, negative 1. And finally, your input of 2 should have given you an output of negative 3. If you look, you're kind of on the right track. Your points are forming a line, and it's going in a negative direction. When you start from the left, it went down. And I know it's supposed to be negative because of what's here. And again, we're going to talk about that when we move on to our other form of graphing. Okay, let's take a look at our second problem here. These numbers work better when you are dealing with an equation that has a fraction. One of my strategies is if I have to multiply my input, meaning if I'm multiplying my x by a fraction, I always look at whatever the denominator is, and I use multiples of my denominator. What happens is it ends up canceling out your denominator and leaving just the numerator. So it's an easier number to work with. So if we plugged in negative 2, I should have gotten negative 2. If I plug in 0, I'm going to end up with negative 1. And then there you can see my points coming on my graph as I've completed them. If I put an input in of 2, I actually end up with 0. And then with an input of 4, I'm going to end up with 1. So if you take a look, my line, my points, and remember each of these points is a solution to this machine, to this equation. It's an ordered pair that makes the equation true. When I connect them, I now have my straight line, and it's going up in a positive direction. So there is another way to graph an equation, That is using the slope-intercept form. And this is what I touched on earlier. I know it's slope-intercept form because it's in the form of y equals mx plus b. The m represents my slope. It's the number that is being multiplied by my x. It's how steep or how flat or how high my line is. It tells me its steepness. Then in my formula, the b, that is my y-intercept. That is the beginning point of my line. Now, if you look what I circled here in yellow, that is a -6. And I circled the negative because that's important. It's going to tell you where the line starts. Your y-intercept is the place where the line touches the y-axis. So before we can start this, let's go back and review what slope is, because I need to know why I use my slope. My slope is a rise over a run. It's basically the change in my y, so moving from one point to the next point. It's how high up I'm going or how far down I'm going. That's my rise. I can go down when it's a negative. My change in x, that's my run. It's how many I'm going over right or left. Remember, going to the right would be a positive, the left would be a negative. I can see this change also sometimes in a table. You might not always see it in a graph. If you see your ordered pairs, what you would do on your y's is find the change in the y's and then find the change in your x's. And it's always y over x. In order for you to have a linear function, the change in y and the change in x has to be consistent. It has to be constant. So let's go look at the 4 types of slope. I could have a positive slope. A positive slope is when my line is going up. It's like an uphill climb. Now, where we get confusing is, well, where do I start? You always start here on the left of your graph, and you follow along as if you're climbing a hill or you're a skier and you're going uphill. So you're positive. Then another type of slope is negative. Every time we're trying to calculate, I'm starting on the left of my graph. And I follow along the line and it's going down. So it's a downhill climb, which is a negative direction. Then there's 2 other types. I have a zero slope. A zero slope will go from left to right. Okay? An undefined slope goes up and down. So it is important that you study these. If this were me, I would pause it and I would copy these 4 types of slopes and the directions they are going. So why is this form the best form to work with? Because it's very simple and very quick. We can graph this equation a lot faster than using a table. The table method will always work. You can always pick a couple of points, put them in your input, and get an output. I prefer this method. What we have to first do is identify my slope. Well, my slope in this equation is 2. My y-intercept is -6. Remember, your y-intercept is the place where you begin. So I'm going to begin at -6 and put a point there. From that point, we talked about my slope being 2. I'm going to rise 2. Now there's always a run. And if I look at this, I don't see a denominator. But remember, every whole number is over 1. So my run is 1. I now have a point right there. I rose 2 and ran 1. I'm going to do that again, rise 2 and run 1, so I get my 3rd point. If you notice, these are the same 3 points from my table. When I connect them, I have that same line. So it's your turn. Pause the video now and try these two on your own. Let's see how you did. So on my first one, we notice my y-intercept is -4. So I'm going to start with a point at -4. My slope is the same as my last problem, 2, meaning it's a +2. So I'm going to go up 2, and it's over a +1. I'm going to go right 1. I'm going to place another point where I just stopped after rise and run. I then am going to go up another 2 and run another 1, and I've got my point there. I personally like putting 3 points. It gives you more direction of your line. You can even put more than 3. So if we come over here, my y-intercept is a +3. So my slope now has a -1, meaning I'm going to go down 1. But my run is a +2. So then I'm going to go down 2 and right 1. Down 1, I'm sorry, and right 2. Sorry, my other line just finally came through. There's your 2 lines. Now, if I take a look here, okay, let's come out over here. This slope was positive. If I start at the left of my line and trace it, I'm going up. Therefore, a positive slope. This slope over here is negative. If I start at the left of my line and trace it, my hand's going down. Therefore, I graphed it correctly. If you have any questions, feel free to comment below and don't forget to subscribe.